What's going on, guys, and welcome back to the channel. If you're a cannabis connoisseur like myself, you probably are under the impression that you've met all of the cool kids on the block. We know about THC, CBD, CBN, THCP, all of those awesome cannabinoids that we all love to use, synthesize, and produce and sell in various laboratories all across the world. But what if I told you there was a new kid on the block, so fresh and so exclusive that most of the scientific community is just barely getting acquainted? Get ready to meet CBGD. And no, before you jump to conclusions, we are not talking about some rare brain disorder, though I will address that confusion in a second. No pun intended. We are talking about cannabisitol, and this little compound is doing some truly fascinating things. We're going to do a deep dive into what CBGD is, why it's so rare, and the potential implications that it could have for product formulation and the scientific community in the future. By the end of this video, you'll be dropping cannabisitol into random conversations like the well-seasoned phytochemist that I hope all of my viewers are by now. Alright, so let's dive right on into the content. The full name is cannabisitol, and its officially less sexy abbreviation is CBGD. Now, if you've ever Googled CBGD, you might have been met with something a little heavier. That's because CBGD is also the abbreviation for a serious neurodegenerative condition called corticobasal ganglionic degeneration. Not exactly an ideal name clash, right? So for the sake of clarity, when I say CBGD in this video, we're exclusively talking about our new cannabinoid. So where did this new star come from? Well, it was first isolated and identified from, you guessed it, cannabis sativa extracts by a brilliant team of Italian and Swiss researchers, also, good note, directly linked to the research that first gave us all of the psychoactive cannabinoids that we discovered in 2020, THCH, THCP, THCB, and THCM. And we're talking very recently, like we just discovered this in 2025. And you already know it wouldn't be an official WKU consulting video without me at least telling you how it is made and synthesized outside of the natural process. So stick through to the end of the video because you already know the how-to tutorials coming up. The initial scientific paper, which is our main source for all of this information, dropped in the Journal of Natural Products in September 2025. So we're talking about cutting-edge, recently published science right here. Now, this is where CBGD really stands out from the crowd. When you think of cannabinoids, you probably picture single, elegant molecules like CBD or CBG or THC. CBGD, not so much. CBGD is what we call a dimeric cannabinoid. Think of it like this. Instead of being a single Lego brick, it's essentially two Lego bricks that are snapped together somehow. Specifically, it's a methylene-bridged dimeric cannabinoid. That means that two separate cannabinoid molecules are linked by a single carbon atom bridge, a CH2 unit, for all of my chemistry students out there. This structural class is incredibly rare in nature, like unicorn rare. CBGD is only the third methylene-bridged dimeric cannabinoid ever identified from the cannabis plant. The other two are cannabisol, which is a dimer of THC, and cannabitwinol, a dimer of CBD. So CBGD is in some pretty exclusive company. It's not just a new cannabinoid, it's a whole new type of cannabinoid for most phytochemists. If it's so rare, how does the cannabis plant even make it? Well, this is where it gets interesting because CBGD isn't born in the same way as its more famous cousins. You see, most major cannabinoids like THCA or CBDA are created by specific enzymes in the plant, like little molecular factories, but CBGD, it's likely what we call an artifact of chemical reactions within the plant itself. It's thought to be formed through a non-enzymatic dimerization. Imagine two smaller cannabinoid molecules just bumping into each other, and with a little help from a trace amount of a single carbon unit, like formaldehyde, which can show up as a metabolic byproduct or even from external factors, poof, They link up to form CBGD. Also, good to note that instead of formaldehyde, which could exist in, some trace amounts depending on the soil and the different plants that you're growing, also we can make this single carbon bond from mold. Who'd have thought? The accidental formation explains why CBGD is found in incredibly low trace amounts in the plant. It's truly a minor cannabinoid in every sense of the word. You're not going to find strains optimized for CBGD anytime soon because it's not made intentionally by the plant's main machinery. It's more of a happy or perhaps unhappy chemical accident. Alright, so enough about its structure and origin story. What does the mysterious dimeric cannabinoid do? And this is where things get truly, truly fascinating, especially in the world of medicinal cannabis science. The initial research on CBGD focused heavily on its potential effects on the skin, and we are still unraveling more and more and more with every passing day, and the results are incredibly promising. The study demonstrates that CBGD exhibits remarkable antioxidant and skin anti-inflammatory activity. Let me repeat that. Remarkable. Profound. They found its anti-inflammatory effect to be significantly higher than that of CBDD, its dimeric cousin, which is significantly higher than CBD. So it's not just anti-inflammatory, it's super anti-inflammatory compared to the cannabinoids that we have tested on similar basis. So how does it work? Well, it's not necessarily through the same pathways as THC or CBD. The study found that the CBGD works by inhibiting the NF-κB pathway. This cannabinoid works by inhibiting the NF-κB pathway. Think of the NF-κB pathway as the body's master switch for inflammation. When it's flipped on, it tells your cells to pump out inflammatory compounds. By inhibiting this pathway, CBGD essentially helps turn down that inflammatory response in skin cells. This is a big deal because many inflammatory skin conditions are driven by an overreactive NF-κB pathway. You can see where we're talking about potentially the fountain of youth, especially in cosmetic products. What does this mean for us? Imagine this compound helping with conditions like eczema, psoriasis, or even just general skin irritation and redness. It's a brand new angle for cannabinoid research, potentially unlocking a new generation of skincare. Yeah, bro. Cool story, but, tell us how to make it already. That's why we stuck around to the end of the video. Anyway, well, you are in luck. Essentially, this is a very simplified reaction. Not a lot going on here. This is just a simple reflux apparatus. All of these things should seem very familiar to you. And all that happens is CBD is reacted with a 1:3 molar ratio or 6 equivalent of formaldehyde under reflux at 78 degrees Celsius in ethanol for 48 hours. So CBD, formaldehyde, ethanol, and of course your water chiller at -10 degrees Celsius at least. And then you will just slowly ramp up the temperature until you observe a slight reflux. Remember, you never want your level to go over about 75% of the condenser. If you are, turn your heat down, but approximately 78 degrees Celsius in ethanol for about 48 hours. The yield is incredibly low at about 19% maximum yield efficiency was all we were able to achieve. So not great, but it is a possibility that once further research is established, we can begin to isolate that cannabinoid via either chromatography or something along that lines to purify it and make sure that it goes as a active ingredient in whatever product formulation. Also, due to note, you still need to extract it from the formaldehyde and the ethanol after it has been reacted. So all of that, understanding of how to clean up and work up your reaction, absolutely key there. We also have significant research now that clearly links aging to chronic low-grade inflammation. This is a phenomenon known as inflammaging. This type of inflammation is associated with so many age-related diseases, heart disease, cancer, diabetes, so on and so forth. So when I say that CBGD literally is going to revolutionize the way that we use cannabinoids for medicinal purposes, The implications here are profound, So, there you have it. Cannabisitol, or CBGD, a truly unique dimeric cannabinoid found in tiny amounts, not made by traditional enzymatic processes, but with remarkable potential as an anti-inflammatory and antioxidant in our skin. The discovery is that a fantastic reminder that we are still so early in the stages of development for medicinal cannabinoids, and hopefully, God willing, we will be able to get some of the, high-powered, monetary, economically powered big pharma institutions to realize that this is could quite literally be a game changer for much of the ways that we think about, conditions that most people just learn to live with or medicate on severely in their day-to-day lives. Do you use any of your, let's say, cannabinoid? I know a lot of people out there use it for recreational use, but are any of you still using it for medicinal purposes? And maybe let us know down in the chat what some of those medicinal purposes may be. We know that there's great studies on all of them. Guys, I hope that you found this video helpful and informative to shed some light and also give you an exciting scope on the future. We are still discovering new compounds, still discovering new ways to manufacture those compounds in isolation and to be able to make product formulation out of them. So it is a great time. It is a great and exciting time for the cannabis industry as a whole, and I'm so happy to have had you here throughout all of this. Today marks our 4-year anniversary since starting the channel, and I must say it has been a blessing and a privilege to teach and consult and be and just live in the cannabis industry with all of you guys. If you liked this video, I have no doubt that you will like one of these videos popping over my shoulder, and it has been a blessing, a privilege, nay, an honor to be able to help, teach, and consult with you today. We'll see you in the next one. Peace.